Hi, I'm Chris Wilson. You may recognize me as one of the creators of Path of Exile. When people hear that I co-founded Grinding Gear Games with my friends back in 2006 when I was 24 years old, they often ask how I got the experience needed to be able to start such a large project at a relatively young age. This video is about how I've been making games since I was 7 years old. It'll hopefully also be an interesting look at what it was like learning to code and develop games in the 80s and 90s. Back in 1987, when I was 5, my parents bought their first computer, a Commodore Amiga 500. This was a really special computer. Its graphics, sound, and multitasking capabilities were half a decade ahead of PCs at the time. It wasn't until the day that Wolfenstein 3D came out that Amiga zealots like me stopped repeating this in every conversation. My parents thought they were buying this computer for themselves, but they were actually buying it for me. They just didn't know it at the time. I lived and breathed this machine. I still have it right here, almost 40 years later. Unfortunately, this computer was built way closer to the moon landing than the present day, so a lot of its capacitors have deteriorated and I can't boot it up to show it to you in action today. Like most 5-year-olds, I initially just consumed games on my computer and hadn't yet contemplated the idea of making my own. But at age 6, something special happened. You see, at the time it was common for books and magazines to have source code listings for programs you can type into your computer at home. This was pretty impractical, of course, because if you get one symbol wrong, the program just doesn't work. At the time, my grandmother was visiting from England and had shown an interest in my computer use. She wanted to encourage me to do something more educational than just playing games, so she offered to read one of these program listings out loud while I typed it in. After hours of dictating and typing, the program didn't work. It turns out it was for the wrong type of computer, and that the version of the basic programming language on the Amiga was just too modern to be compatible with this particular game. I feel comfortable blaming my reading comprehension for this because I was 6 years old, so I was quite new to reading as well. My parents absolutely loved everything about this though. Not only was I spending time with my grandmother, but I was showing interest in learning something complicated and potentially useful. So they bought me the correct programming book for the language and computer I was using. Just seeing this thing brings back so many memories of my childhood. I carried it everywhere with me. I probably read it 50 times. When I typed in programs from it, they worked. And when I read about how commands worked and I modified the programs in the book, my modifications did what I wanted. It felt so powerful being able to control a computer in this way. I spent so much time as a 7-year-old learning about how every aspect of the computer could be programmed. Here's a photo of me coding on my Amiga from around this time. When I was 8 years old, we went on a family holiday to Fiji. I wouldn't have access to a computer while I was there, so I planned ahead and brought my programming book with me. At the time, I was trying to make a game that looked like those early King's Quest games from Sierra. One problem I faced was how to read in and draw sprite data for a fish that I wanted to jump out of a lake. Without access to a computer, I had to draw the pixel art by hand on grid paper and handwrite the code to iterate over a set of data statements and plot them on screen to draw the sprite. It was while I was working on this that I had an idea. I vividly remember sitting in the kids' swimming pool at the Plantation Island Resort in Fiji and having this epiphany that I could potentially use decimal point notation to address pixels to try to get more resolution out of my monitor, like addressing pixel 3.5 rather than 3 or 4. Obviously, this isn't actually how monitors work, and I was 8 years old at the time, so I didn't know that. As soon as I got back to New Zealand, I tried out my idea and was disappointed that it didn't work. A few months later, when I was 9 years old, I realized that if you draw an image using coordinates that can be scaled at runtime by dividing by some value, you could simulate objects getting smaller, like they're getting further away from the camera. I remember making a spaceship game this way. It certainly wasn't anywhere near real 3D, but kind of gave the impression of it. This interest in rudimentary graphics programming caused me to request 2 more books from my parents for my 10th birthday. I remember being the happiest boy ever when I got to open up Amiga 3D graphic programming in BASIC. It teaches all of the 3D math required to write a ray tracer with reflections and shadows. This book was way above my ability level. It wasn't until I was at university years later that I was able to fully understand it, but it was an amazing inspiration for me at the time. The idea that it was possible to create graphics like this if I just knew the math for it was probably the reason why I studied so hard at school as a teenager. The other book, Amiga Machine Language, was more immediately useful. Each month I spent my pocket money on a copy of the Amiga Format magazine. And conveniently, the same month that I was given the assembly book for my 10th birthday, they gave out a free copy of the DevPack assembler on the magazine's cover disc. This issue of the magazine had an article written by Bullfrog, developers of Syndicate and Theme Park and so on, showing you how to move sprites around in assembly language. I spent a lot of time trying to learn Motorola 68K assembly, but I was never particularly good at it. It definitely helped build an understanding of how computers work at a really low level though. Decades later, a programmer at GGG was surprised when I helped him debug a problem by suggesting that we drop down to view the raw assembly language representation of what the compiler had generated. I don't even know if he had any idea that I was a programmer myself. I wrote so many small games for the Amiga before I was a teenager, and I'm considering putting the work in to get my Amiga working again so I can see if my old programming disk from 35 years ago still works. When I was 13, we got a PC with Windows 95. I spent a lot of time programming in QuickBasic. I taught myself Turbo Pascal, then C, eventually C++ using DGGPP and the Allegro library for graphics. Things progressed more quickly from there. By age 14, once you've already spent years programming, you can make progress surprisingly quickly. I was learning new techniques and exploring new languages constantly. I remember having a lot of conversations with my high school friend Luke about how to render 3D graphics in real time. I had the book from when I was 10, of course, but not only was the math way too hard still, but it was also oriented towards ray tracing. This was a few decades before hardware was powerful enough to do that in real time. While we were trying to puzzle out 3D graphics programming, Luke and I went on our fourth form school camp. One of the parent helpers was a professor at Auckland University who happened to specialize in 3D graphics programming. I have this memory of us waiting in line to do some obstacle course where we're peppering this poor guy with questions about how to transform matrices correctly. He patiently explained the answers to us while trying to keep all the children safe on the obstacle course. It was helpful to get this exposure to graphics programming as a teenager because it meant that I knew to pay special attention when we were doing advanced linear algebra in high school. At around 16, I became obsessed with Intel x86 assembly language and started writing little utilities in it. Inspired by the demo scene, I tried to optimize the size of my executables to be as small as possible. Towards the end of high school, I went to use the library computer to do some programming during my lunch break, and there was a kid already sitting there, coding away. It was apparent that despite being a few years younger than me, he was an exceptional programmer. He introduced himself as Jonathan Rogers, and we became friends. Years later, we would co-found Grinding Gear Games together. In my first year of university, I started developing an ambitious space MMO with some of my friends. This project was a very good lesson about scoping a game to be far too big. Development was mysteriously cut short that year when Diablo 2 released. In fact, when I was looking through the project source code recently, I noticed that the last file modification date was literally the day that Diablo 2 came out. I found my computer science degree relatively easy because I already knew how to code. This let me focus my attention on my finance degree and learning computer science concepts I hadn't been exposed to through my own study, like searching, sorting, and algorithmic complexity. After Jonathan finished university a few years later, we got together with our friends Eric Olofsson and Brian Weissman and founded Grinding Gear Games, creating Path of Exile together. That story is long enough that it's going to have to be another video, of course. While all of this makes it sound like I was an amazing programmer, I wasn't. I was just passionate and really loved learning all the technical details. I was average at actually writing code. When we worked out the responsibilities for Path of Exile, it was apparent that Jonathan was leagues ahead of me as a programmer, and that's why he was the technical director on Path of Exile. I didn't even write that much code for PoE myself, as my responsibility was doing all of the non-code, non-art parts of the project like design, production, and business. By that point, I had 17 years of hobby game development experience, and this was incredibly helpful for me knowing how things worked, and greatly increased the chances that an ambitious project like Path of Exile would actually be successful. All of this happened because I was privileged enough to be in a situation where my parents bought me a computer with a programming environment when I was a young child. When I showed an interest in coding, they got me books and whatever resources I needed. I was incredibly lucky that my parents were supportive and that they could afford to buy these tools for me. We certainly weren't that well off, but there are families out there that would just not have been able to justify these expenses. I believe that being lucky enough to get this exposure to programming at a young age substantially changed the course of my life. This realization is what led to my charity focusing on schools in New Zealand where families can't afford coding lessons, and then funding those lessons so that young kids from every background can get exposure to programming at that key age. A lot of parents ask me for advice on how they can nurture their child's interest in computers and programming. While we do live in the golden age of infinite, easily accessible free tutorial content and resources online, it's all a lot more complex than it was back in the 80s. Back then, things were very simple and computers came with programming languages built in. A lot of the early 80s computers would boot right up into a basic prompt, and that's where you'd launch programs from. These days, you have to install specialized programming tools that generally don't come with your computer. BASIC was also far simpler and easier for kids to understand than modern programming languages like Python or JavaScript, where you have to worry about indentation and parentheses. I suspect this is why parents often start their children on visual block-based languages like Scratch. My general advice is to just let your kids explore. If they're driving where their interest is going themselves, they'll find it far more fun and far less like homework. The advantage of starting programming so early is that they have a lot of time to develop their knowledge through exploration, and they aren't on a clock where they need to progress through topics or they'll fall behind their peers. I will be forever thankful that my parents nurtured my interest in game development at a young age, as it's given me a career and a hobby that have both been so enjoyable. If you enjoyed this video, please like it and consider subscribing. Thanks very much, and I'll see you next time.